Hello and welcome to the C programming lecture on basic input and output. So the C standard library has a variety of different ways that it handles input and output. Now for our use case, we're just going to be concerned with what we consider these file descriptors. So at this point in the course, we've actually been dealing with output just a particular terminal. However, the C standard library actually gives you something called a file descriptor, which abstracts all of these different output types. So for files, typically we have a file type is actually defined inside of the C standard library, and this represents a concept of a stream. So a stream could be anything from a file to a USB drive, it doesn't really matter what it could be and where the actual file is stored or how it's inputting, outputting. It could be a keyboard input. It could be, a variety of different things. This is just a way for us to abstract that particular thought process. So let's go ahead and talk about what we've been using recently. So every time we've used a printf function, we've actually been using a particular file called the Stdin. Now, by default, a Linux shell gives you 3 standard file descriptors. So that's Stdin, Stdout, Stderr. So these 3 here. Now the printf function that we've been using, like I said, has been using Stdout this entire time. In order to read data from Stdout, the actual header stdio.h contains convenient functions like scanf or a variety of different other functions that can actually read from this particular device. So here's an example of how we can read input using the scanf function. And again, we're talking about stdin. So we're outputting the std out and we're reading from std in. So here we have a variable declared x that's on line 5. We request the user to input data by saying enter in a number. We enter in that number, and the scanf function, when this program runs, it actually halts the program and waits for the user to hit the return key. And once the return key has been entered, it will then continue this particular function, and then it will print out line 9, which will be the number that we entered. So we can see in our output, it's a little hard to tell what's going on because this output is just a screenshot, but we'll see in our live code editing portion how this works. Okay, so some edge cases for scanf. Now, like I said, there's a variety of different functions included inside the stdio.h header. However, we're just to keep things simple, for where we'd like to read strings and stuff like that, we'll just be using scanf. So the scanf function will read in chunks of a string. So meaning when you want to read in particular chunks of a contiguous string that you're typing in, that's what you would use. So it's important to use the man pages in order to see the different parameters and formatted strings of examples for scanf. Again, this is something that I mentioned at the beginning of the course. Man pages are particularly useful. If you can't find the information that you are seeking, then reach out to the internet and try to find examples over there. So on a side note, it's often noted that scanf is actually considered unsafe. And the reason why it's considered unsafe is because there's something that we already know about called a buffer overflow that can occur. And the reason is because we basically pass it a buffer to fill, but the input could be larger than the buffer, and then we can overwrite particular memory. So this isn't good. There's actually another function that we can use that we can pass in a length that we know that's been well defined. So as stated before, there's several different functions for handling input and output. These are all given in the C standard library, but for the time being, and just to get a general introduction to all of these things, we're just going to keep it very basic and simple. Okay, so here's the example of a two buffers. So I have a f underscore buffer, which is 32, a length of 32. It's a character buffer, so it's a string. So it's a character array, which is also a string, and it's 32 characters wide, or in other words, 32 bytes wide. So both of these buffers contain 32 bytes. And what we're going to ask for, and you can see here how I was talking about how we have segmented strings, we're going to ask for you to format your name just like this. So we say, please enter first and last name. Here's an example. And we have two %s's, which indicates to scanf how to read in these particular variables that we're entering in. So you can see in the first line of output, that's exactly what happens. I type my name, and then the output values are the actual buffer values that we pass to scanf. Okay, so I've said the word a few times now, and I believe in other lectures, but I haven't explicitly defined what it is. What is a buffer? So a buffer is, whenever you hear that term, you can consider it a temporary storage area. All the input and output devices contain buffers to read and write to. The Stdin library has a few different functions that allow us to store buffer characters or Stdin with its own temporary buffer. So we'll be looking at a function called getS and fgets. So the getS function has actually been deprecated, and again, this is due to the potential to cause a buffer overflow. But think of a buffer as basically just a array of whatever size you need, and you can store values into it, and that's pretty much it. Okay, so here's getS, and the reason why you don't want to use it is because this particular function is because, as this warning says on the right, you can see that it's dangerous and should not be used. It's actually indicating that there could be a buffer overflow, which could cause code execution that you do not want to happen in your program. Okay, so we have a buffer of size 20. We're going to say enter a series of texts, and then we have this getS function that we pass into the buffer, and then we output that. So you can see here testing. Here's the actual text that we use to standard out, and within here is the text that is then displayed on standard out, but also placed in standard in. So we see the getS function when we pass the buffer, and then we output it again to standard out in printf on line 11 that the buffer contains the exact input that we placed in. Okay, now let's talk buffer overflow. So we've kind of seen this already, but in this particular case, I wanted to show you exactly what could occur here. So we have a character buffer of length 10. Now this buffer we can pass into the getS just like the prior example. However, when we write it this time, we wrote a series of text that is much larger than 10 characters. Now you'll see here that it starts typing out. This is more than 10 chars of text. And then eventually the program does a segmentation fault. Now again, this is considered a buffer overflow. The reason is because we're accessing memory that we should not be. And the segmentation fault doesn't necessarily have to happen every time, but in this particular instance it did. So again, this is the reason why it is noted not to use getS. So the alternative is the fgets function. So we're going to go ahead and use that one. Inside of this function, it's actually required that you pass in a series of text that is a length, right? So you've seen me define this macro before in other videos. It's basically just getting the length of an array, and that's pretty much it. And it's the buffer size will give you the length of the actual whole array right here on the left, and then on the right it's an individual element, which will give me the actual byte size of each element. So this will just give me the actual length that we need. So you can see inside this, we are using the same series of text. So this is a series of text longer than 10. And we can see that actually the fgetc function, when we pass the buffer, the length, and then where we're receiving it from, so Stdin, that it will not actually do a buffer overflow. And the reason is because we're passing in that length, it knows not to continue to overwrite memory that it doesn't need to based on that length. So that's the alternative, really, that you should be using. So let's go ahead and dissect a buffer overflow. We've kind of already looked at this again, but I kind of want to spend a little bit more time now that we've been talking about it so much. So buffer overflow occurs when a program begins to write out of the boundary of a particular buffer. So again, this was in the array example. I believe I did something similar. So it starts to write to adjacent memory locations, which again, I believe that we displayed. So in other words, we can write to a particular amount of data to an allotted amount of memory until the end of that block is hit and continue to write past it. Now, you know, in some cases you may not be allowed to, and in others it may be perfectly fine. The program will not crash, and you can actually exploit programs this way. So it's important to at least know this. This is why I'm also covering this again. So, okay, let's go ahead and go over this buffer overflow example. So what we're doing here is we're creating a character buffer of length 10. We're going to go ahead and create a integer of, you know, just regular old 0 value here. Now what we're going to do is we're actually going to print out x, print out this statement here that says enter in a series of text. Then we have a getS buffer function call, or passing in our buffer into getS. Again, remember that this is a function call that allows a buffer overflow, so no good. This next line here, we see that we're outputting the text, and the following line we are actually, so we're outputting the buffer in line 14, and line 16 we're actually outputting x. So if you know exactly what you're doing and how the memory is segmented, you can actually create this particular output. Now we compile the program, we execute the program, we see our first value printed out here as x. We enter in a series of texts. So you can see that, again, here's program compilation. We actually get a warning, and we can see that the input 10 characters, so we input 10 characters to reach the limit of the buffer. So that's this A, B, C, D, E, F, G, H, I, J, right? So that is the 10 character limit. So then we write the value of A at the very end, right? So recall that the getS function allows a buffer overflow. So what occurs is at the very end, it's going to write that to some other memory address. So if you recall from the previous slide, what do? We get the buffer and then we print out x. So nowhere in here are we assigning the value x to anything. But if we look back at the output at the very end, we have a 65. And the reason is why this is 65 is because this last capital A actually overwrote in memory the memory address that is synonymous with the variable x. And you can see that here at the last line. Okay, so just kind of, again, hammering away what is actually going on here. Imagine this is a diagram of our particular memory addresses. So memory addresses 1 through A is our entire 10 character buffer. You can see 1 through 9 and then A representing the value 10 here. So we have 10 elements, and then the next element is actually our x value. So, you know, this paints a pretty good picture of exactly what was going on. This, once we reached 10, we actually went to 11, which was past this actual addressable space for our buffer, and then started overriding the values inside of our x variable. So moving on to creating files. So again, there's file descriptors inside of C programming. So what we're going to use is files, like fairly simple for doing input output. So we can either open up a already created file or write to an already created file. And there's a particularly good function called fopen, and this is again defined inside the stdio header. So again, specifically, there's a file type, and this file type is going to hold information about a stream. A file can be actually created using this fopen function as well. It's pretty a versatile function for different types of operations. It should return a pointer to a particular file type as well. So in order to enter into specific modes, you can see that the second parameter, we have this modes pointer here. Now there's different types that we can enter into. So we have a read, R for read, and a W for write, and an A for append. Now, depending on how these are implemented, they relatively work the same. Pull up a man page and read more about them to get a better overview of what they may do. So on a successful call to fopen, a subsequent call to fclose passing the actual file pointer is required to avoid something called a file handle leak. Now, a file handle leak is actually something that can cause a pretty big headache for you. So just remember, whenever you're creating programs and that are opening files, you need to, at some point in that lifetime of that file or that program, you need to close it. So to avoid something called a file handle leak. All right, so here we go. We're going to go ahead and create a program inside of this example that does just creates a file. So you can see here on the left, we have a particular file and we're saying write. This is going to indicate that we're going to be able to create this file if it does not exist. So we're going to open up this file. If it's null, we're going to print out an error. We have some other error handling functions that we haven't quite gone over, but these are actually included inside this error_no.h header. And we don't have to really worry about these too much, but we, just write it as you see it. And if you're interested, look up the man page, search online. But for our use case, we're more along the lines concerned with these stdio header functions. So we're going to open up this file. We're going to print out some information here saying that the file was successfully created, and then we're going to close that file. So we can see here that we compile the program, run the program, list out all the directory contents, and we can see that we have our file, and the size of that file, there's nothing in it, it's 0 bytes. Okay, now we're going to go ahead and look at writing files. So we've now created files. Now we want to write to them. So after successfully obtaining a file pointer, there's a variety of ways that we can read, write, and all types of things that I've been talking about within this lecture. For now, we're going to stick with the basic fprintf function. This is also declared an stdio header. So here is an example of us actually writing to a particular file. So again, we do the same exact thing. We have a file that we created or we open. And what we're going to do is we're going to output that the file was successfully created. And then after it was stated that it was successfully created, we're going to actually output a series of text here into the file. And you can see this fprintf takes the file pointer and then a series of text. And then we close that file on line 17. So you see this program on the right compiled. We have GCC compiling this particular program, and then we execute the program, we list the directory content, and then we actually use cat to list out every single line inside this particular file, my_file_name. Okay, now we're going to talk about reading from files. So similar to writing files, the C standard library provides various ways for us to read from a particular file. We're going to go ahead and review two different approaches from reading from files. We're going to use the fgetc and fgets. The major difference being fgetc returns just the next character in the stream, and fgets reads in at most one less than the size passed into the buffer. So that meaning that we read character by character, or we pass in a buffer to read into a particular buffer size. Okay, so here's an example of fgetc. It's pretty straightforward. We're actually using quite a bit of code here, but we open up our file. We have a mobydic.txt, which is a pretty large file. We're going to check to see if it's available. And then we're going to call a function that we created called readline_v1 that takes in a file pointer. Now what we're doing here is we have a do while loop. That do while loop is actually going to get the first character. The put character is actually going to display that. And then it's going to go ahead and check to make sure that this EOF, the character that we receive, is not EOF. So EOF stands for end of file. We are just checking to make sure our output is what we expect. Okay, so just to show you how large exactly this mobydic.txt file is, we can see here when we list out this particular block size for this text file, it's actually pretty large, pretty large in comparison to our other files. We have 644 KB. All right, so here is a video of the output of this file, and I thought this was the best way to kind of show you. And you can see from that, it's quite a lot of text. So that went pretty fast using fgetc. All right, we're going to basically do the same exact thing, except this time we're going to write it using a buffer. Now in this particular buffer, we're going to create something that is going to read the file exactly the same way. However, we're going to also have a buffer of memory that we use instead of getting it character by character. Now, you can see here that our readline_v2, again, like I said, line 26 creates a buffer, 256 character buffer. We're going to get that. We're going to use our getS, pass in the buffer, pass in the length of that, and then we're also going to pass in the file that we're going to be reading from. And we're basically going to check to make sure that that particular function doesn't return a null. And so we're going to keep reading until this function returns a null. And we are just going to output that, and at the end, just again, print out our new line. Okay, so again, same exact size, nothing's changed. We'll compile the program, and we're going to go ahead and watch a video of it executing. So once again, here is another video of us using fgetS this time. Again, pretty fast, same exact file, same exact result, just using two different ways to do it. So now I want to talk about something pretty unique. This is seeking in a file, and just moving around files, and generally how to work your way back and forth between any file that you're working with. You can think of what we're talking about as a cursor inside of a text file. So seeking occurs in a file whenever it is read or written to. Once again, the Stdin library has a variety of different ways, different functions that it offers for what I like to think of as a cursor. So we'll be taking a look at two functions in particular that make this process a little bit easier. We're going to use something called fseek and ftel. So ftel is going to actually tell you the current position inside the stream, and fseek will allow you to set a position. So here is an example of fgets and ftel. So again, we're using that same file, the mobydic file, and inside that file, we're going to go ahead and we're going to open it up. We're going to grab the actual file size. And what does this file size do? Well, if we look at the very bottom, at our actual function that we define, it takes in a file pointer. We seek to the end of it on line 31. That's exactly what this line does. We pass in the file pointer. The second variable is not too important right now, but we're just telling it to, okay, go ahead and seek to the end of this file. And then what we do is we say, okay, tell me the position of this file using ftel, and then we can go ahead and reset it to set back to the beginning. Okay, by saying fset, and this is going to be the offset, and we're saying offset it to 0, so just basically go all the way back to the beginning. So from here, what's going to occur is we have a read line, and in this particular read line, we are going to do the exact same thing as we did previously. we are going to read line by line our file using a buffer. So just like we saw in the prior example. And you can see in the output here, what is occurring is that we are compiling our program, and we run the program. There's a segment of text instead this time. And the reason why there's only a segment of text is that we can see after we get the size and before we call the readLine function, we actually reset our position by calling fseek on line 22. And that's the reason why we have this segmented text here. And we can also see that we actually output the size of this particular file. Okay, so if this is a little confusing for you, don't worry. We can cover this stuff inside of our live coding example, and also we can work through some more examples that may refine things for you a bit more. So let's just do a brief overview of exactly what's going on. The Stderr library gives the programmer various ways of handling input and output of streams with an abstraction called a file type. A file descriptor of the C programming language type file. Okay, so with that being said, like I was saying prior, these are typically called file descriptors, or in some other operating systems, they may be referred to as handles. It's important to close these quote-unquote handles or file descriptors because they can lead to something called handle leaks. So in other words, not closing them could result in the operating system running out of handles to hand out, which would not be good. So in Linux, the stdin and stdout and err are also file descriptors. So it's just kind of important to remember that. So this has already kind of been a lengthy lecture. Let's just dig into some code and just work around stuff to figure out how these things work. Okay, welcome back to our C programming session. And this session we went over just basic handling of input and output. Now, there was a lot of different ways to handle input and output, so we're just going to go over some really basic ways to handle some input-output, otherwise known as I/O. So before we start, as always, create our main.c file. Go ahead and open this guy up. And we're going to go ahead and create our boilerplate code here. It's just standard hello world. Look at this input-output. No real input besides my keystrokes, and the only output will be hello world. Okay, great. So everything's working just as expected. Now we can actually get into the crux of things. So first thing we're going to want to do is let's go ahead and create a file. So let's create something that we're going to write into. So let's call this file handle a write fwrite. And what we're going to do is we're going to go ahead and open this guy up. And let's call him something, the file name something like file, temp file. And since we're going to be writing into it, just want that to be a W. And now what we're going to do is we'll just have an if statement here to check if write does not equal, or if it equals null, right? So if it equals null, then we probably have an error. So just to keep things pretty simple, error opening file, something along those lines. And then we just return, let's just say 1 as our exit code. So now what we're going to do is let's create a new function too. Let's say we'll have a new function, something like write, let's just say random lines, pass in a file pointer like so, copy this guy. And now what we're going to do is we're just going to have this write out some data for us into this particular file. So how are we going to do that? Well, let's use some of the random functions. So if we go to the man page and type in ran, we'll notice that ran is a generated pseudo random bytes thing that we can use. We're not looking at the OpenSSL ran, or we're looking for cran, so maybe it's something different. But ran generally is what the function we're going to be using. So if we look at sran, this is what we are going to be using in general. So yeah, this is what we want. So we need to include the std lib. Let's go ahead and do that real quick. include stdlib.h. Perfect. And now what we're going to want to do inside of here, because maybe we're going to want to just output some random values. Let's keep it at a seed that we know we can always, you know, keep in mind. So this is going to be unsigned. So let's just make this the value, let's say 100. Why not? Okay, so within here, what I want to do is create a for loop that is going to be, let's say we have so we'll say just like all right, we'll have an X and Y, and our Y is going to control how far up and down we are in this particular case. So we'll set it to 0. We'll say, let's write about 100 lines. And inside of this line, we can just output a large series of different random numbers, but let's just go ahead and write another for loop, and this will be our X, if that makes sense. So we'll just go ahead and write 10 values, and in that 10 values, we will stop. So what we can do is say printf. We're going to pass in the file, and here we need our particular random number here. So we're going to go ahead and call ran, like so. So this is seeding the pseudo random number generation, and this is just calling the ran function, which will give us exactly what we need. So there's actually a fputc, which is similar to putc, and I believe that it goes the character first. So we want a new line, because after every 10 pseudo random number generations that occur, after all 10 of those that are on the same line, we want to go to a new line. All right, great. So now what we want to do is pass an f here. And okay, so just to ensure that since we're writing a lot of stuff, we don't necessarily absolutely have to call this, but there is a function called fflush, and this just guarantees that we if we read it here, for output streams, fflush forces a write of all user space buffer data for a given output or update stream via the stream's underlying write function. So let's just go ahead and just call this just to be safe. We're going to flush that. And that being, we're not going to do it at every write, we can do it at the end. So we're going to flush it to force a write at the end after writing into here. Okay, great. So let's go ahead and just compile this program and make sure it's working. Okay, so I see a temp file. Let's open this guy up. And I don't see anything written to it yet because we haven't called our write random file lines. So let's go ahead and call that. So we at least know the first few lines are working. And because we didn't do this before, which is not good, we want to just make sure we're going to go ahead and close this file handle, which is write, like so. Yes. Okay. So GC may not see. There we go. And then what we can do is open up, let's see, cat the temp file, and is it out there yet? Cat the temp file, and there we go. Okay, so there's our output. We can go ahead and just rerun this, but I don't think it's going to refresh since we are technically not appending. Now if we wanted to append, well, it is, if we change this, it probably would append actually. The reason why it would be the same numbers every time is because we're using the same seed value. So let's go ahead and rerun that. Yeah, so that's exactly what's occurring. So I can keep running this and it will be the same values, but if I come into here and, you know, say 201, GCC main.c, rerun that, it'll kind of shift things around. So that's just kind of some pseudo random number generation for you guys. You can look into that if you're more interested in it. So anyways, now we're writing data. Perfect. That's exactly what we want. Let's go ahead and start reading stuff now. So we're basically going to grab this same exact block of code up here. But now what we're going to want to do is we're going to say, instead of a write handle, we're going to want a read handle. So we're going to say read, and we're going to make sure that this read handle, read, it's not null. If not, we're going to print out our error here saying, you know, whoa, things aren't working. Let's make sure that in this time we call fclose on our read handle. And now what we're going to want to do is let's create our function readLines. So we have readLines. It's going to take in the exact same function signature, go all the way to the bottom. And this is basically going to work exactly the same way as our buffer read write. And what we're going to do is we're going to actually set we're going to make a buffer, right? So we can make it, I don't know, let's just say 256. That seems like a good number. We'll just do this to make sure things are zeroed out. And then let's see, what else we want to do? We want to actually just start looping over some of this this file data that we're getting. So we're going to say fgets. We're going to use a safer one. We're going to pass in the buffer. We're going to pass in the buffer size, and then we're going to pass in the file handle, which is our parameter. Okay, great. So if you recall, we need to make sure that this return value of this function does not equal null. When it's null, we want to make sure we break out, and then we also say put char, and we're outputting to the screen a new line to make sure things are not cluttered up. All right, great. So we're going to go ahead and print f. This is going to be a %s because it's a string buffer. And there we go. That's exactly what we need. Just make sure that we're compiling. We are. So now at the very end here, we're going to say read lines. And in read lines, we just pass in the f read handle. And let's close this guy out. And let's expand this a bit. Compile, run. And there we go. So this is just a very brief example of how we can read and write files. I know that was kind of a lot of code thrown out there at once, but you know, this is a pretty simple program, and what it does, I know I introduced a few concepts that may seem a little foreign. The pseudo random number generation. This just is a seed, and what that means is anytime you change this, it will it should produce the same pseudo random number generation. Like I said, you can read more into that. It isn't really important in this case. But, you know, we introduced a lot of different various functions that we didn't have throughout the lecture. But, you know, I figured this was a good example to at least get your feet wet. You know, try messing around with this stuff. You know, try creating like maybe a note-taking application that saves your notes into a particular file, and then maybe it reads it back out to you based on, you know, some input that you give it, or perhaps list out them out. You know, just try to figure out ways that you can work with some of this standard library code. Okay, cool. Well, thanks for joining me on this lecture, and we're getting pretty close to the end here, so thanks for sticking it out.